Okay, now members, let us see these two examples, but now this case, we are still on the horizontal plane, but the force is inclined at an angle. So the previous lessons we've been seeing when the force is applied horizontally, but now this force is going to be applied at an angle, so that's what we are going to see. So a 20 kg mass lies on a rough horizontal plane. If the coefficient of friction is 0.5 and the magnitude of the force P pulling the mass, if it's applied 60 degrees to the horizontal. So this force is this mass is just lying on a ground, so meaning it is not having an acceleration. Okay, so now we draw a simple sketch. So this is what we have as our mass. It's having 20 kilograms. Of course, because of that mass, we are going to express a weight of the mass times gravity. We're also going to be having a reaction. So now the force, remember if this is our horizontal, the force is applied there, but they are doing that at an angle of 60 degrees. So this angle here is 60 degrees. So this is our force P. Now from there, you see that if the body is going to move in this direction, we are going to have a friction which is going to be opposing it. And then as that, the coefficient of friction mu is equal to 0.5. So from there now, we are going to ably come to our thing here. Now, because this force is moving at an angle, it means that the starting point is we resolve it. So we are going to resolve it like this, and then we shall move up in that direction. So we will now resolve this. Now, because this is adjacent, means it will be the force, then this is adjacent. Adjacent goes with cos. So cos of that angle, and because this is opposite, opposite goes with sine. So sine of that angle. So now from there, we can come, and then if we have resolved it vertically, we have R in that direction. R going in that direction, because there is not any movement upwards. So that's why I have R. Then plus, remember this force is also going upwards, P sine 60 degrees equaling to now 20 B. So from there, you can see we are going to be having this side of 60 is known. So P, R plus P into root 3 over 2. These are special angles equaling to 20 into 9.8. Our side 60 is root 3 over 2. So from there, if I make R the subject, I'll take this beside my R will be, this is going to give me 196, then minus, this will be root 3 P all over 2, and I call this equation 1. So now, I come now to this, let me resolve now, horizontally. So the force which is pulling us in that direction is going to be, first of all, P cos 60 degrees. Then there is something opposing, which is the frictional force, F, will be equal to, those are the only two forces we have, this and this horizontally. It will be equal to the mass, which is then, but because the body is just lying on a plane, then this is going to cancel to 0. So that our P cos 60 degrees is equal to F. But remember, our F is equal to mu R. So from there, my P into 0.5 cos of 60 is that, equal to mu. My mu is what? My mu is 0.5 into now R. My R, which is 196 minus root 3 over 2P. So it's that this one is going to cancel with that. So I'll be having my P, and bring this minus root 3 over 2P equaling to 196. So that my P into 1 plus root 3 over 2 will be equal to 196. If I divide through, be 196 over 1 plus root 3 over 2. So my P, how will we press? We first say, how do you press this? We say root 3 equals divided by 2. You press equals plus 1. You press equals. Then you say 196 divided by answer equals. This will give me 100p.0361 newtons. That would be the answer there. Okay, so we note here that cos 60 is 0.5. Don't ask where is it coming from. Those are special angles. Okay, then you now handle this one. A force P is applied on a 600 rod at an angle of 45 degrees. If the angle of friction is 30, find the magnitude of the force P required to cause an acceleration of 2.5 meters per second. So they are giving us the angle of friction. I think that's the angle of friction is 30 degrees. So that is okay. So if they give us the angle of friction, it means that we can ably get the mu. Remember our time, lambda, is equaling to mu. So implying my time of 30 will be equaling to mu. My time of 30 is a special angle, which is 1 over root 3 will be equaling to our mu. So this one is known now. And then from there, we can sketch. I have a body. It's 600 kilograms, meaning the weight, we shall get the mass times the gravity. We are going to be having a reaction. Now this body, there is a force, but it's applied. This is our force, P. Is applied 45 degrees to the horizontal. This is our horizontal. So there is a force, of course, which is going to oppose that motion like that. So basically, when you have this, the idea when you see that we have an angle at which the force is applied on the horizontal plane, start by resolving it. So you resolve that, and also in that order, you also resolve it. Now you see this one is adjacent to this angle, so it will be now P cos 45. Whenever this is opposite, it becomes opposite, it goes with the side in SOHCAHTOA. So sine 45. So after doing that, the rest are going to be very easy. So now, if you resolve upwards, we are not going to have any motion, an acceleration upwards. So that's why you say acceleration upwards is 0. So you have R, then plus our P is also upwards. P sine 45 equaling to now 600 G. So that my R will be equaling to 600 G minus P sine 45. I call this equation 1. Now I resolve in this direction. Now in this direction, I'm going to have an acceleration. Our acceleration here, we need an acceleration of 2.5. So that's why I have to consider that with care. Let me write here 2.5. Because I'm seeing I'm most likely to use this space here. Okay, so now if you have resolved in that direction, first of all you have P cos 45. This cos 45 minus F, because it's opposing, it will be equaling to M, the mass. Remember, our resultant force, I would have started with that. Okay, our mass 600, then times the acceleration, which is 2.5. What have we used? Here we have used the resultant force, or is from here, our resultant force is equaling to MA. As simple as that. So now, remember this one is known. Our P cos 45, then minus mu R will be equal to 2. When we simplify that, we get 1,500. So now, if we substitute there our R, allow me now to use this part here. Now if we substitute our R, we are going to be, remember cos 45 is root 2. Okay, it's 1 over root 2 minus mu. My mu is 1 over root 3 into our R. Our R is here, 600 d minus p sine 45 equal to 100. So from there, our p, 1 over root 2 minus 1 over root 3 into 600 d, and minus, this would be p over root 2, because sine 45 is that 100. So there we are seeing that orange, sine 45 the same as cos 45, all of them equal to 1 over root 2, which would be root 2 over 2 if we rationalize. Okay, so from there, if I open brackets and I bring this side, I'll be having now, when I bring this, I'll be having now p over root 2, then plus this and this, p over root 6, this and this, they are going to multiply, then minus 600d over root 3 equal to 150. When I take everything this side, so our p into 1 over root 2 plus 1 over root 6 will be equal to 1500 minus, now it's going to become a plus 60d over root 3. And so my p is going to be 1500 plus 600, 9.8 over root 3. Now I divide it with 1 over root 2 plus 1 over root 6. And so my p, how do you press this? You start by pressing 600 times 9.8. You press equals, you say, divide by 3. You say equals. Now you say plus 1500. You say equals. Now you say divide. Now you open the brackets. You say 1 over root 2, then plus 1 over root 3, cross the brackets, answer equal to. So the first p is going to be 3810.83 newtons. So that is going to be the force that will require us to cause this acceleration. So that's how we have for now. Now the next lesson we are going to see now inclined planes. See you there.